Welcome to Orchestrate All the Things. I'm George Anatiotis and we'll be connecting the dots together. Stories about technology, data, AI, and media and how they flow into each other, shaping our lives. What is a universal semantic layer and how is it different from a semantic layer? Are there actual semantics involved? Who uses that? How? And what for? When Cube co-founder Artyom Keydunov started hacking away a Slack chatbot back in 2017, he probably didn't have answers to those questions. All he wanted to do was find a way to access data using a text interface, and Slack seemed like a good place to do that. Keydunov had plenty of time to experiment, validate, and develop Cube, as well as get insights along the way. We caught up and talked about all of the above, as well as Cube's latest features and open source core. I hope you will enjoy this. If you like my work on Orchestrate All the Things, you can subscribe to my podcast, available on all major platforms, my self-published newsletter, also syndicated on Substack, HackerNoon, Medium, and DZone, or follow Orchestrate All the Things on your social media of choice.
My name is Artyom. I'm co-founder and CEO at Cube. My background is in computer science, software engineering, data engineering. I started Cube and as a side project, actually, back in 2017 or so. And I started with the idea to build a Slack bot. That was like a first side project. Let's just try to build a Slack bot before bots were kind of all over hyped, before LLMs. And I built that Slack bot, and for myself, for my company, and that Slack bot was able to get data from different places, connect to different systems, organize them into a single data model, and push that kind of information into Slack. But by building that side project, I and my co-founder now, who joined quickly to work on that StatsBot, we built Cube. And then we decided to open source Cube, and then we eventually built a company around that. So that's an interesting kind of story, that Cube as a project really kind of been created as a side effect of another project which is no longer around. And I felt like it's a very common story. So yeah, we started Cube as an open source in 2019, and then in 2020 we built a company around it. And now I'm currently co-founder and CEO.
Okay, yeah, indeed, I wouldn't have guessed that what you do now, which is basically all around semantic layers, started out as a Slack bot. And to be honest, I don't really see the connection. So how did you start building Slack bot and ended up doing semantic layers?
Right. Yeah. So I think when you think about the problem, if you wanted to build a bot, right, like whether you would have a good LLM as we have right now, or back then, like 7 years ago without LLM, regardless, they're like, if you want your Slack, if you want your chatbot to be able to access data in warehouses or databases, you need to break it down into 2 steps. So one step would be how I go from natural language to some multidimensional data model representation, and then how I go from that sort of a data model to SQL. So it's really almost impossible to go from text to SQL directly. So you need to go from text to like a data model, and from data model to SQL essentially. So that's how Cube kind of been created, because when I was working in my co-founder, we were working on that Slack bot. We built this intermediate layer, which is Cube now. So our bot was able to go from text to data model, and then from data model to the query in a database or data warehouse. So, and now, even now, if you think about using it with LLM, that's what a lot of people do right now with Cube. It's just kind of, like we come in a full circle here, but people building chatbots with Cube right now. And what they're doing is that they take in all the context from a Cube semantic layer, and they use this context to generate correct SQL queries. So that's essentially why we started Cube in the first place. So that's a connection.
Well, yes, it does make more sense now, because either I missed it or maybe you didn't mention it, but when you talked about the Slack bots, I missed the part when you said what exactly the Slack bot was supposed to do. And I'm guessing, based on what you just said from the context, that the purpose of a Slack bot was to actually serve as a textual interface to query, I don't know, a data warehouse or something like this, right? So now it does make sense. I can see the connection indeed.
Right. Yeah. And you're right. That's what this Slack bot was doing. So idea was that, like a lot of teams, they were using Slack, still using Slack, and they have a lot of different systems to access data. And the idea was, what if we can bring this data right directly into the Slack, right? So you still in a Slack, you do all this, like a conversation, discussion, but what if you can just pull your data, say from Salesforce or from, like some performance analytics from like a New Relic or some other system right into Slack. So you can just do a query right directly in Slack with natural language. So that was an idea to and pull the data from different sources and put it into Slack.
So I think the key, well, at least in some ways, the key to all that is what you just said. So data from different sources. As long as you're only querying a single data source, then that also implies you have like a single schema. So things are relatively straightforward. It starts getting much more complicated as soon as you add data sources, because in all likelihood, your two or more data sources will not have the same schema, or maybe they don't have a schema at all. And so you have to somehow start mapping things, basically. And I guess that's what semantic layers are all about. And so there's a number of things that we would like to cover in this conversation, and also the fact that's mentioned that you have some news coming up, which we're going to touch upon. But I think it's best if we start from the actual definition of a semantic layer, because I think for many people it may not be entirely clear. So how would you define what you do? So what constitutes a semantic layer?
I think we all used semantic layers in a way that I define it during, like in our sort of a professional work at some point when we used BI. So many of, like us used some business intelligence tools at some point, right? Like we kind of drag and drop chart measures dimensions onto the canvas to build chart, right? Like thinking about Tableau or some other BI tool. So that is essentially semantic layer. When we do something like a drag and dropping, what BI tool does, it takes our metrics, our measures from the UI, and then it translates them into the query to the underlying data source. In many cases, it's a SQL data source nowadays. It used to be sometimes something different, especially back then. But today's semantic layer inside of BI tools, they essentially take measures, take dimensions, all of this high-level business objects, revenue, active users, all these definitions, and then translate them down to the underlying SQL queries. And sometimes it's not one-to-one. So sometimes, like you bring multiple measures, multiple dimensions, and they can translate into multiple SQL queries because you need to do more like a complicated calculations to get to these metrics and then do some post-processing even. But at the end of the day, it's how we go from a business level definitions, business level metrics into the database SQL queries. And the semantic layer as an idea is not new. It's been around for a while, since the first days of the business intelligence. In fact, business objects, they had a patent for sort of a semantic layer idea in 90s. And then MicroStrategy successfully defended against it. And then the interesting problem happened, and why Cube and idea of universal semantic layer is relevant now is, as we went from first wave of BI, where we had one big BI tool like business objects or MicroStrategy being used inside organization, we went from that wave to this current wave where we have just explosion of different data visualization and data consumption tools within organization. So more data consumers, they wanted to access data in more self-service way. There's like a whole idea of democratizing data, right? So we want to give more tools to data consumers to like slice and dice differently data however they want. But it also comes with a cost of having more tools. And a cloud architecture made it really easier. So it's easier to buy new tools, and there are like a lot of BI tools out there. So what's happening is that in organization right now, you have like a 10 BI tools and 20 BI tools, and every BI tool it has a semantic layer. Now what's happening, you sort of kind of multiply your semantic layers inside your organization. And the problem is that you don't know which one is correct. You might have one BI tool with all the metrics and the second BI tool with all sort of the same metrics, and they are not going to be in sync. It's always in engineering when we repeat ourselves, like the system is going to be error prone. It's going to be not in sync, not consistent. We even have this idea of dry, right? Do not repeat yourself. So essentially what we're doing with this universal semantic layer now is we're trying to apply dry principle to the data architecture at scale. So idea is that we say, okay, you have all these 10 BI tools, they all have semantic layers, they all have definitions. You probably don't want it to repeat yourself and build the same metric across multiple systems. So let's take out the definition, put it in one place where you can have it under the version control, you can have all the best practices, how you want to manage your metric, and then just use that metric across all of these BI tools. And if you want to add 10 more BI tools, just add them. You still have your metrics in a single place. So that's an idea about universal semantic layer.
In a way, it sounds like a new twist to an old problem. I mean, you could be in pretty much the same situation if you had, it sounds like a kind of meta layer in a way. So yes, indeed, you did have semantic layers ever since you had BI tools, but now, as you're describing, because of the fact that you have many BI tools, you need to go like one level up and define like a meta semantic layer to talk to all these different semantic layers. So it's like integrating different databases with different schemas in a way, just on a different level.
Right. Yeah. Correct. I think that really the problem here comes with just a scale of the stack. If you have only one BI and you're going to use only one BI your entire life, right, in an organization, you probably don't need an extra semantic layer. What you have inside that BI is fine, but that's realistically not going to happen, right? People are going to use Excel, Google spreadsheets, custom build applications, all of that. So at this point, you really need a way to make sure that your semantic layer can work outside of your BI tool, right? Like, because if it's only working within that BI tool and, like Google spreadsheet is not using the metrics, or Excel users are not using the metrics, defining that BI tool, that's really bad because you want that same metrics be consistent across the organization.
The difference, with database analogy, let's say, is that at least in the database scenario, assuming you're talking about relational database, you do have a standard that you can reuse. So you can always, if you have your queries, you can always revert, let's say, to using ANSI SQL, and you're pretty certain that your query will work across your databases. But how do you ensure that your definitions will actually work across your different BI tools? Because do you have something like a SQL for metrics?
That's a great question. Yeah, I think, like we call it and think about it as an interoperability, right? Like when I think about the semantic layer, the data modeling is extremely important layer. Is like how we help users to build the actual metrics. But then the other important metric layer is how people can actually use these metrics, right? Interoperability. So Cube currently we have several APIs. So one API is just a REST API, and you can sort of sister API to that is GraphQL. So that's being usually used if you wanted to build your own application or to query data programmatically. So you can just send a JSON structured query or GraphQL structured query with all like a list of measures, dimensions, filters, and just retrieve the data back. The other interface we have is a SQL. So Cube pretends to be a Postgres database and C-compatible Postgres database. The only caveat here is that tables in this database, we call them views internally in Cube. They are sort of a multidimensional. It means that they're not real. They're not materialized, right? And then we actually materialize them on a fly when you query them. So that's sort of like a caveat here. But the system can generate the legit SQL. It's Postgres compatible. We support all the different SQL functions. And this way, tools like Tableau, and other BI tool can connect it to Cube. And the other layer we support now is MDX. That's for more like Excel, Power BI, Microsoft ecosystem, because that's the most common query language in the Microsoft ecosystem. And then we are soon going to support DAX as well, because DAX seems going to replace MDX eventually. Is kind of Microsoft pushing more DAX right now rather than MDX.
So if I get it correctly, then those different ways, let's say, of interacting with the underlying BI tools have to do with execution time, really. But how about the actual definition of metrics? So if I want to define something like, I don't know, sales per quarter or whatever, do I have like a lingua franca that I can use to do that?
Yeah, the way we think about it is it's all code. So the Cube is one of the big philosophies at Cube is being a code first. So your data model essentially is just a code base. It's a set of YAML files or Python files. So we use YAML for most of it because it's declarative. It's easier to define. So if you want to create a measure, for example, sales per quarter, right? You can just put a 5 lines of YAML as a definition, and then you're going to get that measure. If you want to do more like a complex things, sometimes you can write a Python code to make more like a dynamic imperative things. But most of our customers, most of our users, when they build data model in Cube, they just use YAML definitions. So that's YAML code base. You put it under the version control. You use something like a GitHub to manage the version control, and then you just add more definitions to it. I think the way we think about developing data model is more like a software. So if you wanted to add a new measure, a new dimension, you would go into feature branch, like create a new measure dimension, put it on staging environment, test things. If if it makes sense, then you can merge it, and then you can have a pull request review process and all of that. But at the end of the day, just a code base.
Okay, that's an interesting idea. It just makes me wonder. You said that the majority of your users work with YAML files, so it makes me wonder what are the profiles of the majority of your users? Because in my experience, it would be more like the engineering type of person that would be comfortable doing that, not so much the analysts. And in my mind, at least, analysts would be like the number one audience for these BI tools.
Right. Yeah, great question. Yeah, I would say most of our users who are working with data model at Cube directly, they're data engineers. The way I think about it is that if you have a data model semantic layer in your organization, right, that role is essentially sort of a data stewardship, right? It's someone who is building data products, right? Like some measures, dimensions, data model, something that can be used downstream to build visualizations. And the people who are usually building visualizations in tools like Tableau or some other BI tools, that's more like a data analyst, right? Like a people who consume data consumers. So our primary users, I would say, would be more for data stewards, data engineers, people who are building this model. And they're usually more familiar with code-based tools. Especially in the recent years, I feel there is a big movement in the data world to apply software engineering best practices to data management and putting more things into code. Now we see Airflow, like very code first driven there's a Python code, some other tools like a Dexter, Prefect. There are like some transformation tools like SQL Mesh. They're all like code first as well. So it's really like a big movement of making code first workflows in data stack.
Yes, you're right about that. And in many ways, I think there's this idea, this principle, let's say, of applying the same principles that have worked well for software engineering, also in data and data engineering. It's probably a good idea. The hard part, really, in my experience at least, is actually getting non-technical users to do that. So, people, first of all, most of the time they have a bit of issue, let's say, a bit of trouble getting their heads around, the key concepts like pull requests and pushing code and Git and all of those things. But even if they do, then actually doing that, I don't know, firing up an IDE or a command line and just doing those things, I wouldn't really expect business users to be able to do that. So it sounds like the type of user that is the key audience for your tool is actually maybe doing a bit. They're also sitting in the middle in a way. So they're sort of taking the requirements from the business users and trying to translate them into code so that they can work out.
That's correct. I think that's where we are right now. So Cube is all the workflow in Cube is very engineering and technical driven. I think that's a correct foundation how to build infrastructure. But I think you brought an interesting concern. It's like how do we make it more friendly or accessible for more non-technical people to be able to make changes to the data model? I think historically it's been a very big problem in data governance and the data modeling in general is that it's relatively slow moving in a way that if you need to make a change to your data model measure dimension, you need to go through multiple cycles before you can see a result. And if the workflow is a technical, then like non-technical person cannot just do that. They would need to go and like submit a Jira ticket to data engineering team and just kind of wait for the next sprint so that ticket would go in and kind of be finished. I think what opportunity we have now is that with new large language models, they're really good with generating code. We know that. And there are like specifically some models that are really being built for code generation. GitHub Copilot works fine and a lot of users use it. So it's a living example of how LLMs can generate code, which is correct and helpful. So I believe in a future, if you think about it as a data model is just being a code, why LLMs cannot generate that code in future? If we don't have a measure here, why LLM cannot just generate that? Like could develop and fix the data model or do something about it. And if we take these AI agents that can do changes to the data model and pair them with domain experts that should not be technical. They may be like from finance, from a marketing. They just data consumers, but they domain experts. And we pair them with this technical AI agents that can actually make changes to the code base. Then the magic can happen. Then we can iterate on the data model quite fast. But at the same time, we keep the right foundation in place. It's still a code base, meaning that we can apply all the software engineering best practices to it. We can have a pull request review system from a central governance data team. We can do static analysis, impact analysis, CI/CD, all of that. So I think that would be an interesting opportunity in future for us, how to leverage LLMs to move faster with data models.
Interestingly, it sounds like by adding, so initially you had, as you also pointed out, you had this chronic, let's say, situation in that even the slightest change had to go through a long cycles of approval and then implementation and all of that stuff. And the whole idea behind specifically self-service BI tools was to do away with that and kind of make things simpler and faster, having in mind precisely those business users and being able to serve them in that they would, in a way, they wouldn't be dependent on the technical people to implement, even the simplest of changes. And now by adding this universal semantic layer, it sounds like this has sort of coming through the back door again. So we're back in a situation where self-service BI won't cut it.
Yeah, it's always about the balance. So on one side, you have a well-governed data, trusted metrics. On the other side, you have a flexibility and velocity that you want to give to your data consumers. So the question is how you can give that velocity and flexibility, but at the same time still keep the correct governance. Because what could happen? What could go wrong if you give a lot of freedom that people can start building wrong metrics, and these metrics are going to spread across the organization, which is wrong because someone built them And then that person, maybe not a data person at all, they build them, they're wrong, that person quit a job, and then the metrics still remain there. No one knows, who built it, how it's working, but people have built a layers on top of that. And now like a lot of things are broken. So that's problem. But the other problem is that if you put everything into the governance, then you started to move very slow, right? You like people cannot just do ad hoc analysis. So I think what we need to do is we need to give a good layer of data governance that, like we can maintain, the data team can maintain. That's going to be like a gold layer or platinum layer, just a lot of like a reference to, like metals in a data industry. But we can keep that governance layer in place. But on what we also need to support is ability to create ad hoc calculations on top of governed metrics inside these BI tools. So the analyst, the data consumer can go in a BI tool, Tableau, for example, right? Load the data model from Cube into the Tableau just to start doing some analysis. And then they see that the metric is missing. And then they should be able to quickly build maybe LOED calculation in Tableau to test something. And that should be supported on top of these basic metrics. Once it's built, then the question, okay, if it makes sense, we would need to bring it back into the governance layer. And that's where, like the workflow could happen. It could be through the data team in future. It could be through AI agent to make it faster. But we still need to give a way for people to quickly build calculations on the fly, on the edge, to test things, because it's not possible to cover everything inside the data model, inside the governed data model.
Yeah, totally agreed. I was also going to add to what you said, that yes, you're right. You do need to have some sort of process through which you govern your metrics, because otherwise you're going to end up with chaos. But I see that as kind of orthogonal to a universal semantic layer, actually. Another question that I had, actually, as when you mentioned previously that the main way through which you define metrics is actually pretty simple, so YAML files. And I was wondering, because personally I come from a background of, well, more elaborate, let's say, data modeling, so knowledge graphs and ontologies and kind of formal semantics and all of that stuff. And to me, when people talk about semantic layers, always it kind of gets to, so okay, is there anyone using that kind of technology to an actual semantic layer? Have you considered that? Do you think it would make sense to introduce something like that? Or if not, why not?
Right. Yeah, I think the name semantics about semantics or naming is always been a challenge. Even in our industry, when we only started to think about building what we call now universal semantic layer, we had a different names for that type of technology. Some people were calling it metrics layer. Some people were calling it a headless BI. And then eventually, like as an industry, we all arrived on a term semantic models, semantic layer. But at the same time, you're either like, like knowledge graphs and ontologies and all of that. So I would give you a definition and sort of try to scope what we mean by semantic layer at Cube, and what like other technologies in data space specifically mean, in analytics mean by semantic layer, and by others it mostly would be like at scale, DBT, like a Power BI semantic model. So usually it's all about building measures, dimensions, and a relationship between them. So you would have some entities that hold your measures dimension, and these entities are tables essentially, right? It could be materialized tables in your warehouse. It could be virtual tables. These tables, they will hold measures, dimensions, and you will have a relationship between tables that sort of create your data graph. And then you might have some slices of that data graph. So we call them views at Cube. Looker calls them explorers. Power BI calls them perspectives. But essentially just as like a slices of this data graph that you present to the end users. So that's how we all like define semantic layer right now. It's all for analytics purposes. So it's not a general purpose knowledge graph from that perspective, but it's enough to cover analytics use cases.
Let's fast forward a little bit because you actually already mentioned something that hinted to some new features that you're about to release, and I had the chance to read a preview of those features, and it seems like at least a big part of it is centered around using LLMs to do what precisely? As again, a sort of natural language interface for people to define their metrics, or a bit more than that?
Right. Yeah, I kind of mentioned already on one potential use of LLMs with the semantic layer and the data modeling and how LLM can generate and data model. So essentially, if we think about that use case, eventually I believe that LLMs will build and maintain semantic models over time. Right? That might not happen tomorrow, but it will happen over the course of the next few years. That's one use case. The other use case, and that's what we're releasing this week, is how we can leverage semantic layer context and a knowledge to create better AI assistants that can access data in our data warehouses. So if we think about the problem from the engineering standpoint, think it's a text to SQL problem, right? So imagine you need to build an AI agent that should be able to give you the correct answer based on your data in your data warehouse. Maybe it needs to run some calculate the revenue per salesperson and compare that to the average revenue, across all of them, all the account executives. And to do that, the AI agent need to generate a SQL code. It's not a problem to generate a SQL code as to make it just ANSI SQL, because there are so many examples of ANSI SQL on the internet. The problem is that your AI agent, it doesn't know about your metrics. It doesn't know about your data model. If you just give it a table or a set of tables and give a DDL of these tables as a context, it's not going to really learn a lot. It needs to get more prepared data on one hand, so the metrics already defined, but it also needs to get a more context about it. What is that metric? Why it's here? How it connected to that other metric? How that your revenue is connected to actually account executives? What is account executive? How it sits in a organization? So all of this sort of a knowledge or knowledge graph, essentially all this relationship, it needs to have that context. That context can be represented as just a text at the end of the day, describing everything that you have in your data model. So you can take that text and you can give it to LLM. Now your LLM has all this context and it can generate a correct SQL query. You also don't want that LLM to generate query to your end data warehouse, because the query is still going to be big. It might involve multiple joins, all this calculation. So there is a lot of room to make to hallucinate and make a mistake, and it would be hard to debug that. You wanted that to make a query to your semantic layer. So the query is going to be very simple. It's going to be just kind of give me this metric with that dimension and apply that filter. Once you send it all to your semantic layer, the semantic layer can apply the data model it has inside and then generate a real big SQL in more deterministic way, right? And then execute that SQL and send data all the way back to AI agent. So that's what you're releasing as a sort of a first step toward that vision, which is releasing an API endpoint where you would be able to send your natural language query saying hey, I want to look at my average, compare my average, sales with average sales per specific reps in that region. And then the LLM can generate all these queries, run them, execute them, and give you result back. And then you can use it if you're building a chatbot, you can use it directly, or if you're building maybe a more complicated AI agent, you can use it as part of your chain, right? So you can get that result based on this information, apply some other action, and kind of keep it going. It's going to be just an API endpoint that can plug into any chain, into any RAG architecture.
Interesting. So crucially in the process that you mentioned, one crucial part is the context that you also mentioned, which you need to bring in so that the LLM can have the right background information to actually translate that textual input to something more structured to pass on to the semantic layer. How do you actually feed that context to the LLM currently?
It depends. If a data model is not huge, you can just take it and put it into prompt, right? Like as is. If it's a larger context, you probably want to, like turn it into embedding beforehand, and then apply some RAG architecture where you would do like a vector search for the relevant context based on the query you're getting in, and then apply only subset of that context. So like some optimization, you can do that, but it's just from a architecture perspective, like once we have a context, once we able to do all this like metadata indexing, understanding what a relevant information we have, we can turn it into the embeddings, and then from there we're just good to go. We just apply best practices on building RAG architectures.
Okay, so it sounds like you're using a kind of mixed approach. Let's say sometimes you use the context window, sometimes you use RAG, basically. I have a tip here for you just to tie this back into to the previous conversation on knowledge graphs and so on. So actually, some people from the knowledge graph community did an interesting experiment and tried to compare and contrast these two different approaches, specifically on RAG. So in one instance, they do precisely what you are trying to do here. So basically feed context to LLMs in order to access a backend database. So on the one set of experiments, they used the schema information from the database as is basically for the LLM. And in the other instance, in the other set of experiments, they used the same information but morphed into a knowledge graph. And they compared the results in the two sets of experiments, and they found out that by using knowledge graph-based RAG, they had much better results.
Yeah, I think I saw that paper you're referring to, and I remember folks in our community, what they did is that they took that experiment and they run it instead of knowledge graphs, they used Cube semantic layer. And I think they got to even better results. Many things already sort of being pre-calculated in a Cube semantic layer. So if you think about it, going from like a DDL to knowledge graph, it's one improvement, and then going even from knowledge graph to semantic layer, it's another improvement.
Interesting. I didn't know about that last bit. But yeah, I guess it just goes to show that, there's lots of, it's in the early stages, so there's lots of room for improvement, I guess.
Yeah, for sure.
Okay, and the other new feature that I saw you releasing has to do with chart prototyping. So what's that exactly?
Yeah, so Cube is commonly used to build different like data applications. So we're talking a lot about using BI tools and LLMs, right? But sometimes you just need to build your internal data app, maybe like with React or Python or some, like other visualization tool. And you just wanted to present it internally, like to show it to the customers. So we're releasing a way to quickly build, prototype different types of the visualizations on top of Cube. So we are still headless technology, so we're not providing you with a kind of visualization layer, but we give a way to quickly iterate on the different visualization options just to bring it to production sooner. So that's been a very common request from many customers, how they can just quickly prototype charts on top of Cube APIs so they can build different apps.
One kind of closing, I guess, question, because we're almost kind of out of time, I had was, you did mention previously that the core technology at least is open source, and now we are just talking about new features and so on. So I wonder which parts are the core open source ones and which are the value add features. And so if people want to get started with Cube, where do they start and what can they start experimenting with?
Yeah, we have on a cloud. Think about it as our cloud commercial product is just a more feature-rich platform. All like different AI capabilities are built in a cloud platform. Things like a chart prototyping built in a cloud platform. There are like more integration with a BI tool that's built in a cloud platform, like integration with Excel, built in a cloud platform, all of that. But the core data modeling experience, you can create your data model still in open source, right? You can write these YAML files in open source, you can compile them, you can run them. So there is like an open source core. The easiest way to start is just to sign up at the Cube Cloud, cube.dev. That's going to be a cloud product. We have a free tier. It's very generous free tier in a way that you can develop, you can build a stagings and even small production on that. And that would be probably the best way really to start with Cube.
Well, thanks for the conversation. It was a good, interesting one. I learned a few things, which is always what I like to walk away from conversations with, and I hope it was a good one for you as well. And guess we can wrap up right about here, unless there's anything that you feel we didn't cover and we should.
Oh, that was a great conversation. Thank you. I really enjoyed it.
Thanks for sticking around. For more stories like this, check the link in bio and follow Link Data Orchestration.